Welcome back, folks. We're back at Copernicus. There we go. Anyhow, mesh shortcut. Nodal shortcut. I tend to get a little careful with it when I use dependent supplies, but what I know I can do is I can still do it with op amp. So we're going to look at our op amp problems again and throw the shortcut at it. See how quick we can do these, okay? Some people are scared of these. There's absolutely no reason. If you know how to do them the long way and you know how to do them with the shortcut, you can do these with a little practice in about 30 seconds on your calculator. And some people are just intimidated by them. You're better than that. You have the knowledge. You've done the practice. Go ahead and give it a try. Okay, so here's the first one that we looked at. We're going to go through all four. I'll make them short and as short as I can because it's a shortcut. My pen's not working. Hold on. There it is. Got it. Okay. Sorry about that. So let's see. This one's going to be a 3x3 matrix and a 3x1 vector for those three non-reference nodes. So we still do that, just like we would usually. And we set up our matrix. Got it all on the screen here. We invert that matrix and we multiply by the right-hand side. All right. That's going to give us VA, VB, and VC. Okay, so now what we got to do is fill it in. We got to fill it in, but I want you to think about how we make the plan for this circuit. Same plan. We write a KVL for the 10 volt. Okay, so I'll write KVL for A. We write a KVL for the op amp. And we write a KCL. I avoid A because of the voltage supply. I avoid C because of the output of the op amp. And I write a KCL for B. Okay. Now, we follow the same rules, really. So I'm writing a KVL here. What's on the positive side? A. What's on the negative side? Ground, so that doesn't get anything. Everything else is a 0. Okay, VA equals 10. And that one's done. Looking over here at B, now we could get picky and say that, well, it's connected to the negative side. It's going to be -1. And it could be because the other side's 0, right? So it really doesn't matter. Negative VB is going to be 0. It's the same thing as saying VB is 0. So if you want to be consistent, you can do that. But I'll tell you, a lot of times I just drop that off. I'll leave it for now. I should be consistent for you. But a lot of times I just say VB is equal to 0. Okay, 2/3 of the way there, almost done. And we go through the same questions. We're writing a KCL for B. So we say what's connected to B that's also connected to A. And it looks like the 3K. So it's -1/3K. What's connected to B? That's the one I'm writing the equation for. So it's going to be positive. And it's going to be 1/3K plus 1/15K. Okay, and what's connected to B that's also connected to C? And it's just off the screen there, but it's the 15K. So it's -1/15K. Any current supplies connected there? Nope. So we get a 0 on the right-hand side. All that's left to do is calculator work. Okay, let's see, I have the one from yesterday still in here. 1 0 0 10 0 -1 0 0 -3 inverted 3 -3K. I almost forgot the K, right? You're not going to forget the K because you're better than me. Okay, 3K plus 15K, both of those inverted, -15K inverted. Whew, that one takes a little bit longer to enter, but what we come out with is 10 volts, 10 volts, 0 volts, and -50 volts. That feels familiar. It's behind my head. I'll scroll up for you. That feels familiar. It feels like that's what we got from the previous video. Let me just check myself. Video. Getting a little sloppy. Trying to move quick. Oh, I'm at 5 minutes. I can do better. Okay. I had it queued up and then I scrolled. Okay, so I did these a little out of order, but we get the same result from an equivalent system. So we got 10, 0, and negative 50, 10, 0, and negative 50. Looks like I swapped these around, but it's an equivalent system. It gives us the same result. Okay, can I see that negative 50? Maybe if I move out of the way. There you go. All right, there you go. We can do it with op amps. Let's practice it a little bit more. We've got 3 more op amp circuits I want to look at and then do a summary of nodal analysis. That's what's coming next. Stay tuned. Good luck.